We're going to take a look at Venn diagrams. Venn diagrams look like this. It's a box with a couple of circles in it. And they're very useful for sorting and organizing information. It's great to use if you want to compare or contrast, look at the similarities and differences amongst a couple of lists of items. Venn diagrams are great if you have 2 or 3 lists. If you have more than that, it becomes very overwhelming and very difficult to use. Here's an example of a Venn diagram. We have 2 lists, a red list and a green list. And we have 2 circles, a red circle and a green circle. The items that are on the red list go in the red circle. The items that are on the green list go in the green circle. Now down here we have some items that are on both lists. They're red and green. They're on both of those lists. So they have to go on both of the circles. Well, there is a part where that works here. Notice this intersection here is both red and green. So if something is on both of the lists, we write it in the middle in the intersection. Let's see how this actually works. Let's look at a basic example. Luke has a whole bunch of friends, and some of them have cats, some of them have dogs. He decides to make a list, and that's what he does right here. He asks each friend, do you have a cat? Do you have a dog? And he puts a check mark in the appropriate column. Some have only dogs, some have only cats, some have both a dog and a cat. And some of them, like Timmy down here, doesn't have either one. He creates a Venn diagram. Venn diagram has a box, and the box is titled. It's important that your Venn diagram has a title, and the box is what we call the universe. All of his friends will go into that box somewhere, either in one of the circles or outside of it. In the green circle are the people who have cats. We had Jason, Ted, and Lydia who have only cats. They go in the green circle. We have Krista, Paula, and Sasha who had only dogs. They go in the blue circle. Now Luke was a special case. Luke had a dog and a cat. He has to go in both the blue and the green circle. Well, that means he goes in that intersection. That is included in both circles. So Luke's right here in the middle. Luke is a member of the green circle. He has a cat. Luke is a member of the blue circle. He has a dog. He has both. Then there's Timmy. Timmy doesn't have a dog. Timmy doesn't have a cat. So he's outside of those circles, out here in the universe. And it simply says neither. He doesn't have a dog. He doesn't have a cat. Now, could he have a fish? Certainly. Could he have a bird? Yeah, he could have a bird. But our circles are only showing cats and dogs, so he's just sitting out here. Now, the questions that could be asked about this diagram, well, let's see what they have. How many people have only a cat? Well, Jason, Ted, and Lydia have only cats. They're only in the green circle. How many people altogether have a cat? Well, there are 4 people in the green circle. Jason, Ted, Lydia, and Luke. How many people have just a dog? Krista, Paula, and Sasha. We have 3 people who are in only the blue circle. How many people have dogs altogether? Well, we have to add Luke in there. Luke has a dog also. There's a total of 4 people who have dogs. How many people have both pets? Well, that's just Luke, dog and cat. Remember, he's in both circles at the same time. And how many don't have either one? Well, that's Timmy. One person has no dog, no cat. Let's take a look at the next example. In the next example, we've gone up to the Rochester airport, and we're conducting a survey. We're looking at a total of 200 travelers today. And here's what we found out from the security people. 156 cell phones went through the X-ray machine. 72 laptop computers went through the X-ray machine. And 49 of the people who went through had both a computer and a cell phone. So some people went through with just a cell phone, some people went through with just a computer, some people went through with both. All we know is that 49 people had both. There were a total of 156 cell phones and a total of 72 laptops. Let's sort this out using a Venn diagram. So we begin by drawing our rectangle. And let's give this a title. Why don't we call this Electronics at the Airport? Now, first circle is green, that's for cell phones. Second circle is purple, that's for laptop computers. We know 49 people had both. So we have 49 who are in that middle section of the diagram. We know that 72 people had laptops. So there's going to be a total of 72 people in the purple circle. 72 people in this circle altogether. Well, there's already 49 here, and if there's 72 altogether, there must be 23 who had only a laptop. Because 49 and 23 would mean that there were a total of 72 laptop computers that went through the airport that day. Same idea for the cell phone. There were a total of 156 cell phones, 156 people in the green circle. 49 are already in the green circle because we know they had both. How many people had just a cell phone? Well, if there were 49 cell phones already counted here, and there's a total of 156, there must be 107 people who had only a cell phone. And we did the subtraction for that to figure that out. Now, is it possible that some people went through the airport and didn't have a cell phone and didn't have a laptop computer? Certainly. Let's figure this out. 107 plus 49 plus 23, that doesn't add up to 200. It's 21 short. That means there's 21 people, because remember we asked 200. 21 people who did not have a cell phone, did not have a computer. So they go out here, outside of the circles, just as neither. They didn't have a phone, they didn't have the computer. And so we use this Venn diagram to make this nice and simple. Now, this extra information here, once I've filled it in, I don't necessarily have to leave it. All I really need to know is that there are 23 with only a laptop, 107 with only a cell phone, 49 with both, and 21 who had neither item. Take a look at this next example. The next example is a survey of students. We're talking about 3 different clubs: math club, swim team, and the soccer team. Some students are on only the math team. Some students are on only the soccer team. Some students are on only the swim team. Some students are on 2 teams, or maybe 3 teams. This diagram lays that out for us. The first question says, how many people are on all 3 teams combined? Well, that's simple. We just add up all the numbers in here. That gives us 47. There's 47 people on all of these teams combined. The second question, how many people are on all 3 teams? Meaning the math team, the soccer team, and the swim team. They participate in all 3 activities. Well, that's the person who's in all 3 color circles. That would be only this person here. This person is in the blue circle, the green circle, and the red circle. So there's one person who's on all 3 teams. How many people are on the swim team and the soccer team, but not the math team? Well, here's the swim team, here's the soccer team. But we don't want people who are on the math team. Well, swimming and soccer are these sections right here. This is a green circle and it's a blue circle. But we don't want the math people. The math people are the red. So we'll have to cut them out. This little section here is the only one that has people on the swim team and the soccer team both. And so there's a total of 4 who are on those 2 teams, but not the math team. How many people are on none of the 3 teams? They don't participate in the math team, the soccer team, or the swim team. Well, that's these 25 who are outside of the circle. Finally, how many students altogether are there? Well, 25 plus 10 plus 4 plus 15, 3, 1, 2, and 12. Add them all together. There's a total of 72 students who are represented by this diagram. Now, questions can get a little bit trickier where we have to think about it. Take a look at example G. It says how many people are on exactly 2 teams? Well, we have these 4 who are on soccer and swim team. we have these two who are on the swim team and the math team. And we have these three who are on the math team and the soccer team. So 3, 4, and 2 gives us a total of 9. There are 9 people on exactly 2 teams. How many people are on the soccer team? Count the people in all of the green circle. 15, 3, 1, and 4. That gives us a total of 23. And finally, how many people are on only one team? Well, we have these 15 who only play soccer, these 10 who only swim, and these 12 who are only on the math team. 15, 12, and 10 gives us a total of 37. 37 of the students are on exactly one team. Now, Venn diagrams can be simplistic with only 2 circles, or as we saw here, with 3 circles. It gets a little bit more involved. Now, what if we want to fill one of those in? Well, we have an example coming right up of that, because we're celebrating John Venn's birthday. John Venn is the man who's credited with creating the Venn diagram. And at this party, we're serving garden burgers, hamburgers, and hot dogs. And I've shaded in these circles a bit to help us just kind of see what we have going on. Anybody in the green circle had a garden burger. Anybody in the brown circle had a hamburger. And anybody in the red circle had a hot dog. And let's just take a look at the information that they gave us. They said we had a total of 54 people coming to this party. Every guest ate at least one sandwich. 3 people had one of each kind. So there's 3 people who had a hamburger, a hot dog, and a garden burger. So those 3 we'll put into all 3 circles. And notice this section right here is all 3 colors. When we fill these in, we have to start from the most restricted and then work to the least restrictive. If it said 10 people had a hamburger, well, we don't know how many had a hamburger and a hot dog. We don't know how many of those had all 3. We don't know how many had just the hamburger. But if we start with the most restrictive thing, 3 people had one of each, that has to go in this section of the diagram. And then we can work our way through. The next piece said 3 had a hot dog and a hamburger. 3 had only a hot dog and a hamburger. So hot dog and hamburger, it looks like there's 3 in this space here. Those 3 had only a hot dog and a hamburger. The next piece says 4 had only a hamburger and a garden burger. Hamburger is brown, garden burger is green. Only a burger, a hamburger, and a garden burger, there are 4 of them. So we'll put them down here in the green and the brown circle. Now the next piece is a little cryptic. It said 16 had exactly 2 kinds of sandwiches, which means 16 people had either a hamburger and a hot dog and a garden burger, or a hamburger and a garden burger. 16 altogether. Well, these 4 had 2 kinds of sandwiches. These 3 had 2 kinds of sandwiches. So we have 4, 5, 6, 7 people so far who had 3 kinds of sandwiches. And there are 16 people who had 2 different kinds, which means 16 minus 4 minus 3 gives me 9. There are 9 people who had a garden burger and a hot dog. Okay, you can see how these can be tricky. You really have to take your time and try to figure the pieces out. It's really a big puzzle. Finally, it says 23 had a hot dog. So there are 23 people in the red hot dog circle. There's 9 plus 3 plus 3. 9, 12, 15 people so far. And we want a total of 23 in the red circle, which means there are 8 people who had just a hot dog. Now if we add these numbers together, 8, 9, 3, and 3, we'll end up with 23 people who had a hot dog. Now they tell us 7 had only a garden burger. Well, I guess those 7 are right down here. And finally it says, oh, 54 people came to the party. 54 people came to the party. So I guess I'm only missing one section in this diagram. This piece up here, only a hamburger. Everything else is filled in. 7, 9, 8, 3, 3, and 4. And there's 54 total. 20 people must be in here. So there's 20 people who had only a hamburger. Now, that's part A. Question A says how many people had only a hamburger? 20. Part B says how many people had a hot dog and a garden burger, but not a hamburger? Well, that's this section here. Hot dog, garden burger, but there's no brown circle, so they didn't have any hamburgers. And this is a Venn diagram filled out to reflect what people ate at that party. These are probably the hardest ones to figure out because you're given information, you have to piece it together. And we will work some more on these. The key to them really is to practice and to fill in the diagram slowly. Start with the most restrictive piece. If you know that someone had all three of something, you fill that in right away. And you just go through your list and fill in the blanks.